Hello everyone, and welcome to the second lesson in this chapter. We'll be talking about postulates and theorems of parallel lines today, or parallel line theorems and postulates. It all means the same thing. Now, most of these you should have seen when you did the 1.3 investigation. If you haven't, we'll go over in detail, but a lot of this should be review, and then at the end, we're going to have some example problems, both some math problems and some proofs. Let's get started. So, one of the first of these properties is the corresponding angles postulate. Now, this is a huge one, both when it comes to just general solving of math problems and proofs. Okay, because the corresponding angles postulate is a postulate, which means it is something that we accept to be true, and we don't have to prove it. Okay, therefore, it just shows up a lot. And this one states that if a transversal intersects two parallel lines, then each pair of corresponding angles is congruent. So that means that if you're given parallel lines, so if you already know that A and B are parallel, then we know that angle 1 and angle 3 are congruent. We know that 8 is congruent to 6, 2 is congruent to 4, and 7 is congruent to 5. All right, these are all the corresponding angles given these two parallel lines. Now, I do want to point out, this postulate says that if a transversal intersects two parallel lines, this is the very first thing it says. And what I want you to notice here is that you must be given the lines are parallel. Okay, if you are not told that you have parallel lines, this postulate will not work. Okay, because it starts with parallel lines, and then because you have parallel lines, you have congruent angles. If you don't have parallel lines, then you cannot say the angles are parallel. And as always, it must be on this transversal you're talking about. Okay, so even if you have parallel lines in the picture somewhere, okay, if the lines that your transversal intersects aren't parallel, then it doesn't work. Okay? Let's keep going. Now, on this slide, we have our interior angles theorem. So both of these are talking about interior angles. The first one is talking about alternate interior. So I left my picture on the last slide. Let me go ahead and get a good one on this slide. And here we go. Now, alternate interior angles is if, again, you have a transversal intersecting two parallel lines, and then that makes the alternate interior angles congruent. So in this picture, angles 2 and 6 and angles 7 and 3 are alternate interior, and therefore they are congruent. Now, the other one here is consecutive interior angles, or as I will sometimes call it, same side interior angles. And this one states that given two parallel lines cut by a transversal, the same side interior angles are supplementary. Okay, so that means that the measure of angle 2 plus the measure of angle 3 is equal to 180. And then the same goes for the measure of angle 7 plus the measure of angle 6. Now, since both of these are theorems, you can prove these. In fact, on the 3.1 investigation, you should have solved and proved for 2. I want to say alternate interior angles and maybe same side interior angles, but you can prove all of these. In fact, some of these are in their textbook, so if you're curious, you can go look. We may even solve some of them for the homework. You never know. A couple more. On this slide, we have our exterior angles. So alternate exterior angle theorem, and then same side or consecutive angles theorem. Okay? You can use the same picture as before, or you can do a different picture. Doesn't matter. I'm going to do the same picture real fast. Okay. Again, both of these theorems have parallel lines. Your lines must be parallel, and they must be cut by a transversal. If you don't have parallel lines, then it doesn't work. And I keep stressing this point because there will be problems where the lines look parallel or they're just not parallel. Okay, and then they'll ask you to solve for the angles, and it's kind of a trick question. It's not really, but it's there to see how many of you guys forget that you need parallel lines first before you can say the angles are congruent or supplementary. Now, alternate interior angles, if you have the parallel lines and all that fun stuff, then the alternate exterior angles are congruent. Okay? So 1 and 5, 8 and 4. Those would be my congruent pairs in this picture. And then consecutive exterior angles, that would be 1 and 4, and then 8 and 5. And those are supplementary. Now this one is not in the textbook, but you can prove it because it is a theorem, and therefore we include it because you can prove it. For example, to prove this verbally, I know that the measure of angle 7 plus the measure of angle 6 is equal to 180. Why? Because of the same side interior angles theorem from the last slide. Next, I know that angle 1, measure of angle 1, is equal to the measure of angle 7, and the measure of angle 4 is equal to the measure of angle 6. This is because of vertical angles. Okay, 1 is vertical to 7, 6 is vertical to 4. Now what I can do is I can substitute these values in, and all of a sudden I have the measure of angle 1 plus the measure of angle 4 is equal to 180. And lo and behold, there I have my same side exterior angles are supplementary. Okay? And that's just the verbal one done real quickly. Now, all of these theorems and these postulates you can have on your packet that you can use on tests and quizzes. Again, that packet has to be done in your handwriting, and it has to be printed in order to be used on tests and quizzes. Now, last one is the perpendicular transversal theorem. Now, this one's a little special, primarily because this name is not in the textbook. Okay, I think we made that name up. The theorem is in the textbook, but I'm pretty sure we made the name up, but that's what it does. So it's a decent name. Now, the perpendicular transversal theorem states that in a plane, so these have to be coplanar, if you have two parallel lines and one of those lines is intersected by a perpendicular transversal, so I'll do this one in green, red, keeping with the color scheme. So the transversal is perpendicular to one of the parallel lines, then it must be perpendicular to the other of the parallel lines. Okay? And again, you can do a real quick verbal proof of this. Like all theorems, this can be proven. So if I have angle 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Here are my angles. Now, I already know that the measure of angle 2 is equal to the measure of angle 6. Why? Because of the corresponding angles postulate. Actually, this postulate says congruent, so let's be accurate. There, they are congruent. And then they're equal because of the definition of congruency. Therefore, if the measure of angle 2 is equal to 90, so that's what we're given first, then this would be our given. Then the measure of angle 6 must also be 90 because of a simple substitution or transitive, one of the two. Okay? And that's just a real quick verbal proof. Of course, we would, if we actually were proving this, we would need to state the lines are parallel first, since that is one of our givens in the proof, or in the theorem. This is just a verbal proof. All right, let's keep going. Now, in the 3.1 investigation, you already did a lot of problems. Those problems probably had one or two parallel lines cut by a single transversal. Let's do a few more complicated examples than that. In this picture, I am told the measure of angle 9 is 80 and the measure of angle 5 is 68. And I need to find the rest of the angles. As I look at this picture, I want to draw your attention to one important fact. There is only one set of parallel lines, those two right there. We have several transversals. There are actually 4 transversals. However, there's only one set of parallel lines. So you need to pay attention on those. Let's go ahead and get started. So if 9 is 80 and 5 is 68, I'm going to go ahead and do all of my vertical angles and my linear pairs. Okay, because vertical angles and linear pairs don't technically need transversals or anything. They just need intersecting lines. So if 9 is 80, then 11 is 80. If 9 is 80, then 10 has to be 100. And the same thing with 12, because 9 and 11 are vertical, and then 12 and 10 are vertical. Same thing over here. 5 is 68, therefore 7 is 68. And therefore, because of linear pairs, angle 6 is 112, and then because of vertical angles, 8 is 112 as well. Alright, so all I did to solve for these angles is just use my vertical angles theorem and my linear pair knowledge. Okay? Now I can use my parallel line knowledge and we can get started. So if I am looking for angle 12, angle 12 is right there. That one's easy. I solved that one using my linear pair knowledge. The measure of angle 12 is 100. And the reason I know this is because it is a linear pair to angle 9. Next, I'm looking for the measure of angle 1. Now, angle 1 is on transversals W. I'll change color so you can see this. Is on transversals W and P. Okay? However, if I'm looking at transversal W, that means my two intersected lines are P and Q. P and Q are not parallel. Okay, therefore any information, well, there isn't any information. P and Q are not related because P and Q are not parallel. However, if I'm looking and using transversal P, that line intersects lines V and W. And those two lines are parallel. So if I'm going in this direction, if I'm going in this direction right here, I can use all of my parallel line theorems and theorems and postulates that I just learned because these two lines, V and W, are parallel, cut by the transversal P. In which case, angle 1 is corresponding to angle 9. Therefore, the measure of angle 1 is 80 because of the corresponding angle postulate. Yeah. Then, honestly, from here, you've got one of two options. Number one, you can keep doing parallel line facts, or you can do another round of vertical and linear angles, linear pairs. Doesn't matter, it's up to you, whichever one you feel most comfortable with. Okay, let's do one more. Okay, let's go to the bottom row. Now, in the bottom row, you have the same thing. So let's solve for F. So angle F, or problem F, is we're looking for 16. 16 is down here. 16 is on transversals V and P. But the same problem exists. If I use transversal V, then I'm intersecting P and Q, and those two lines aren't related because they're not parallel. However, if I use transversal Q, then it does intersect the parallel lines of W and V. And so again, I can use my parallel line theorems and postulates going this way. Now, 16 is either corresponding to angle 8, or its same side interior to angle 7, or its alternate interior to angle 6. Whichever one you see first is totally fine. I'm going to do alternate interior since we did corresponding at the top. So I'm going to say this is 112 because of alternate interior angles. All right, the video is going to pause. Go ahead and solve for the other angles. And here you go. Please make sure that you do have the angle symbols because you are dealing with angles, and then you have the correct theorem or postulate little symbol. Now, one thing you may notice in my answers is I either did corresponding angles or alternate interior, exterior. I like those because you have congruent angles. You don't have to do math. But if you saw same side interior, or if you did another version of linear pair, all of those work. Okay? Let's keep going. Now this problem is one you will see in your homework. All right. This problem deals with another theorem that we didn't write down earlier, but you can still include on your packet. This one I'm going to call the third parallel line theorem, okay, or some variation of that. And this theorem states, it's in your book, this theorem states if you have two parallel lines, there exists other lines that are parallel to them. Now, like all theorems, this one can be proven. However, we're going to just focus on solving the problem, and we can prove this one at a later date. Now, in this picture, we have two parallel lines. However, they're not cut by the same transversal. Notice that this top line, if I were to extend it, it intersects over here. And this bottom line, if I were to extend it, it intersects over there. Okay? So it doesn't, the same transversal doesn't intersect the parallel lines. Which means we cannot use any of the postulates or theorems that we so lovingly wrote down earlier. However, we can use this one. And the way you use this one is by drawing what is called an auxiliary line. Now, an auxiliary line is just an extra line that is drawn to help with a proof or a problem. So we can draw in our auxiliary lines. We can actually draw as many of these as we want. But the fewer pieces of information you add, the simpler your problem is. So I'm only going to add one auxiliary line to this problem, and I'm going to do it so that I cut angle 1 right down the middle. And I'm also going to do it so that it is parallel to the other two lines using the third angle line theorem. Okay. Now I have two parallel lines. I'll just name these L, A, and M. L and A are cut by a transversal. A and M are cut by a transversal. And now I can use my parallel line facts. So using alternate interior angles, these two angles right here are 36. And using alternate interior angles again, these two angles right here are 31. Okay, so I actually didn't cut angle 1 in half. I just cut it, separate it into two pieces. Now I can add up these two parts of the angle, and I have the measure of angle 1 is equal to 67. And that is how you solve these types of problems. Now let's do two proofs. Now in these two proofs, I can use any of my postulates and theorems that I have already used in this PowerPoint because you've already proven most of them on the 3.1 investigation. Because we've proven them, we can use them. All right, let's get started. So in this proof, we are told that lines L and M are parallel. That's good because it means we can use all of those facts. And I'm trying to prove that angle 1 and angle 6 are supplementary. So I'm trying to go in this direction. Now, the first thing I notice about angle 1 and angle 6 is that they are not directly related. Okay, they're not alternate interior or alternate exterior. They're not corresponding. They're not same side. Okay, so they're not directly related, which means there's going to be a few more steps. Now, as I'm looking at this, I do notice that 1 is congruent to 4 because of vertical angles. And the nice thing about that is because 4 is supplementary to 6. And that's already half of the thing I'm trying to prove. So I'm going to go in that direction. I'm going to say that angle 4 and angle 6 are supplementary due to, so take my notes, angle 4 plus the measure of angle 6 equals 180. And I know that because of the same side interior angle theorem. And then I know that the measure of angle 1 is equal to the measure of angle 4 because of the vertical angle theorem. As a reminder, I'm trying to somehow prove that the measure of angle 1 plus the measure of angle 6 is equal to 180. All right, that's the step I got to get to before I can say my last step of the words. All right, here we go. So I have that L is parallel to M, and this is my given. Then I'm going to start with vertical angles. I'm going to start with angle 1, so I know that the measure, whoops, no I don't. I know that angle 1 is congruent to angle 4 because of the vertical angle theorem. And this is where knowing these theorems gets really important. The vertical angle theorem states the two angles, vertical angles, are congruent. It does not say equal, okay? Which means we need a step in there that says the measure of angle 1 is equal to the measure of angle 4. And this is because of the definition of congruency. My congruency symbols are off today, guys. My apologies. All right, next I'm going to say that the measure of angle 4 plus the measure of angle 6 is equal to 180 because of same side interior angles theorem. Okay, this is a theorem. We proved it. Now everything is set, and I can go ahead and say the measure of angle 1 plus the measure of angle 6 is equal to the measure of 180. And I know this because all I had to do was substitute the measure of angle 1 in for the measure of angle 4. So that's going to be substitution. Last but not least, I have the step I was going for, so I can now say that angle 1 and angle 6 are supplementary due to the definition of supplementary angles. Sign off, and you're done. Now, if you were just watching me do this proof, that's totally fine. What I do want you to do, though, is on a separate sheet of paper or a little further down in your notes, whatever, try to do this proof again by yourself, okay? Or maybe first try to explain it to yourself the same way I explained it to you. Remember, all proofs are obvious once someone else has done them. Okay, you only really know that you can do them and that you understand them if you do it for yourself. So, cover up the answer, do what you got to do, but try to solve this proof again on your own. Let's do one more proof. Now, on this one, I'll talk you through my notes, and I'll talk you through the beginning of the problem, and then the video will pause, and you can do the proof, and when it plays again, you'll see the whole answer that I came up with. All right. Let's get started. Now in this one, I see that line P is parallel to line Q. That's good. Now I can use my postulates and theorems. And I also know that angle 5 is a right angle. Good to know. And I'm trying to prove that angle 1 is a right angle. Okay, so the step I need before I can go to my proof is the measure of angle 1 is equal to 90. Well, as I look at my picture over here, I see that 1 is vertical to 5, and because they're vertical angles, that means that 1 is congruent to 5. Okay, so if 5 is 90, that means 1 must also be 90. Okay, so that's the direction I'm going to go in. That's the direction hopefully you can go in. The video is going to pause now. See what you can do. How'd you do? Alright, now if some of your steps are a little scrambled, that's fine. The important things you needed to say is you needed to have said that the measure of angle 5 was 90 before you try any variation or substitution here at the end. Okay? Likewise, you needed to have said the two angles were equal to each other before you use substitution again. because there is no substitution property of congruence. Okay? So as you're looking at my proof, I started off with that the measure of angle 5, well, I started off with my given. But then I said the measure of angle 5 is equal to 90 because of the definition of right angles. That's how I knew. And then I knew that the two angles, like I said earlier, 1 and 5, were congruent because of the vertical angles theorem. Then, because the two angles were congruent, I knew they were equal. And because they were equal, I knew I could substitute in the value of 90 for the measure of angle 5. And that's how I got this next step. That was the step I was looking for before I went to my last one. And therefore I said that the angle 1 is right because of the definition of right angles. Okay, hopefully you got it right, or you got it mostly right, or you got really, really close. Again, I highly, highly, highly encourage you to cover up the proof and try to do it again on your own, the way you can practice, and the way you can know for sure that you know what you're doing. Otherwise, that is the end of this video. Thank you so much, and I'll see you next time.